Alright, so for the facility planning project, we are converting from a straight line to a U-shaped cell design. Group members are Michael Ferris, myself, Tyler Keppel, Christopher Keating, and Cole Rogers. So for this project, the purpose of the entire project was to reduce the overall cost of producing the two products in questions A and B, and converting to a U-shaped cell will basically include drastically reducing waste in respect to the labor. It will improve the efficiency, optimize space utilization, reduce machine idle times, increase profit margins by reducing the total cost. So for the current process, it is a straight line process. There are 7 processes for the two products. You have product A and product B, and the different times at each process. So for the straight line, and we're wanting to convert it to the U shape, we calculated product A and B, the standard time, and how many units we can send out per month. So for product A, we have 9 hours as a standard time. Product B, we have 4.5 hours. Product A, we can produce 22 units per month. Product B, we can produce 55 units per month. And the typical work month would be 22 days. So our assumptions are all workstations are 6 feet long. One worker is currently assigned to each workstation. There's no rework. Workers work 8 hours a shift, one shift a day. The 7 processes do not indicate that there are explicitly 7 workstations. So for the line layout, as you can see up top, the current layout is a straight line with the 7 processes. Our proposed layout is the U-shaped with the 7 processes. So for our U-shaped assumptions, we have that assembly production with some specialized tooling, machining, which could be seen at processes with longer cycle times. We have manually operated machines, hence the various processes. Manual machines means one part can be produced at a time per workstation, and the machines at each workstation can be altered to run either product variation. So for the pros and cons, the advantages of having the U-shaped line would be that it would improve line balancing, increase worker utilization, reduce the space requirements, optimize material handling, create greater visibility of production, and increase the efficiency. So some of the disadvantages are you have initial capital costs for converting, potential productivity downtime, and additional training. So for the workstations on the current method, we have 7 processes and an unconfirmed number of workstations, which is a problem. So for our proposed method of the U-shape, we decided we would have 7 workstations for each of the respective production processes. So to continue on with our workstation layout, we have that the workstation dimensions are 6 foot by 2 foot. Distance between each station is 2 foot. Total area of production cell is 308 feet. The aisle is located on the right side of the cell for incoming raw materials and outgoing finished goods. So for the employee requirements, for the current process of the straight line, we have 1 employee per workstation. Varying time requirements between processes means constantly waiting and creating waste, which is not what we want to do. So for the proposed, we're utilizing 1 employee for multiple workstations. We can reduce the idle time. There's a minimum of 3 employees per workstation / process. to achieve current level of production. So for the responsibilities of the employee, employee 1 is in charge of workstations 1 through 3. This is when the shortest cycle times are resulting in the WIPQ. Employee 2 is in charge of workstations 4 through 5, closed cycle times. Employee 3 is in charge of workstations 6 and 7, which are the longest cycle time and where the finishing process will be. So the key variables for this project is time, cost, and waste. We're wanting to reduce time to bring the product to market. We want to do it in the shortest time. We want to reduce cost. We want to get it cost us the less amount of money. And we want to reduce waste and increase efficiency. So the issues: poor planning, project delay, production delay, safety issues, and quality issues. Poor planning, you have design restrictions, considerations to the building, project delay, when the project exceeds the allotted time, production delays, production schedule, consumer demands are not met, safety issues, construction. Construction will deviate the work environment from normal. Quality issues, the building materials may not be to our required specifications. So the risks include reduced demand, slower return on investment, increased turnover where employees are tasked with more work, inadequate training, employees may not be capable of operating the different machines, and the market value decrease where customers are buying competitors' product. So in closing, the straight line flow is extremely good for high volume manufacturing. The U-shaped flow would greatly benefit this company as we do not produce a relatively high volume. While the initial costs are high, the long-term benefits and competitiveness with the market would increase. The U-shaped flow would allow the cost savings for new technologies to be implemented quicker, and doing nothing will ensure that our competitors have success, and that is something that we don't want. We want success.